Hello everyone, my name is Meethun Panda and I specialize in technology, data and AI helping Fortune 500 companies solve complex business and technical challenges. Today I'll be talking about how to build scalable AI and data solutions using cloud native architecture. Now imagine this, AI systems that scale effortlessly, large data pipelines that adapt in real time, and businesses that continuously innovate faster than ever and without worrying about infrastructure management over it. And that's the really true power of cloud native technology. So let's dive in and explore how it is transforming the way we build and deploy AI. Now, when you look at the trends, what is happening in the industry, we are always obsessed about value creations. So when we think of digital or technology or AI transformations, we always focus on business value creations. Now, cloud adoption has definitely helped organizations accelerate on the business value side of it. However, to make this happen, we must get few things right. The foundation has to be correct. For example, there are certain six key elements that I have mentioned here, starting from building foundation for analytics. You have to have the right foundational platform which will enable your use cases, which will help you accelerate use cases. The second element is the cloud native architecture, which is very important. And cloud native architectures, we are moving away from on-premise to cloud native, which will help us achieve the scaling up or down based on the demand, achieving the fault tolerance side of it with high availability and self-healing mechanism, right? The third piece are rapid value creations. Now, to achieve the rapid value creations, we have to understand the cost side of it as well. And this is financial operations side, FinOps side of it, or the cost efficiency, how we can make sure that we can process the large data and AI workloads while making sure that we are cost efficient, right? And then scaling up the resources seamlessly. That is also very important because we'll be deploying a lot of AI use cases. We'll be building a lot of models and AI models, and this is really necessary that we can scale up the resources seamlessly. As because we are data driven, we are in data driven journey, and making sure that we have the data is governed properly, it is accessible, it's reliable, and it's available. That is really important. These are the three key data enablers we must have to get this right. And then finally, future proof digital advantage, right? We are moving away from on-prem to cloud, and now from cloud to multi-cloud. Again, I'm not saying that on-premise will die here, but definitely we will live in a world where we'll have architecture where which will support very diverse kind of infrastructure. So you have multi-cloud, you have SaaS based applications, you have on-prem applications. Going forward, to understand bit on the cloud native side of it is very foundational on the what cloud native means, which is to design, which is to build, and which is to run applications specifically optimized for cloud applications or the cloud environments, right? So instead of traditional on-premise infrastructures, and we in cloud native applications, it's leverage the true power of the cloud capabilities such as scalability, resilience, automations, and flexibility, so on and so forth, right? So when you look at the scalability, what exactly scalability means is this is where the cloud has the ability to adjust resources based on demand, right? For example, Netflix, it scales its infrastructure during peak hours and scales down during off-peak hours. It's very intelligent, and this is how they scale their recommendation systems and their streaming system as well. When you look at the resilience, it's very simple, right? If something happens, some failure happens, and make sure that your system is so much resilient that it can quickly recover from failures. And the automations, really, we cannot separate automations without DevOps or CI/CD part. And part of it is the infrastructure management, which is infrastructure as a code, such as infrastructure, which is very important to automate deployments. And finally, the flexibility, and flexibility is really super important here, because we need to provide to make sure that okay, this is interoperability across various cloud providers, as because we are going to the multi-cloud journey. Now, all if I sum it up on the cloud native architecture side, it leverages the microservices, the container, some serverless computing, the DevOps CI/CD, and orchestration tools to make sure that it helps us achieve the lower cost or achieve cost efficiency, innovate faster, and optimized performance. Now, to deep dive into just more, and just to take a 1,000-foot view on each of these elements which I just talked about, what exactly mean microservices? Microservices are nothing but applications which are broken down into smaller, independent, and modular services that communicate via APIs. This is very straightforward, microservices. Then we have the containers. What are containers? Container is nothing but a lightweight or which is portable environments for running applications seamlessly across different cloud setups. And then container orchestration such as Kubernetes, which is very popular to manage, scale, and deploy and containerized applications or automate containerized applications. Serverless computing. And this is where we do not need to manage the cloud infrastructure such as AWS Lambda, or in GCP you'll have Google Cloud Functions, in Azure you have Azure Functions. These are the kind of example of computing, and this is really, it helps us without really looking or scratching our head on managing the cloud infrastructure side of it. And then DevOps and CI/CD, I already mentioned the CI/CD side of it, which is DevOps side of it, for the continuous integrations and continuous deployment pipelines for faster deployment and innovations. Now look, now we are building a lot of generative AI models as well. So CI/CD has now been extended to CI/CD CE. So what that means is we are also continuously evaluating the models, right? So that's why I know it's CI/CD and CE, so which is continuous integrations, continuous development, and continuous evaluations. Moving on, again, this is a deep dive on each of these components that I mentioned, looking at how the microservice and the containerized principles help us enable the scalability and resilience. One is the three quick things that I would like to point out here when you look at the data and AI solutions and to scaling up it is independent scaling. Look, so scaling up AI inference separately from data ingestions, right? When you build AI models, basically you have to separate the front end side of it, the back end side of it, the data ingestion side of it, the feature engineering side of it, your AI model development side of it, which is again feature engineering, and the model and the evaluation side of it, AI inference piece of it, right? And this is where the containerization is going to help you. And fault isolation. So if one service goes down, then making sure that another is operational. So it helps us build the resilience side of it. And then the faster deployments, making sure that you are creating a modular, your architecture is modular, and which is going to help you deploy faster. Now on the right hand side, now I've just given one example here. There's tons of examples in the industry that we have seen. In fact, in your organizations, you might already be doing that, right? Leveraging microservices and Kubernetes based architecture, how it really help us scale in building our AI applications or the data driven applications or data centric applications. So for example, it uses microservices and the Kubernetes to scale its AI powered music recommendation engine. Netflix is another great example, right? Where the deployment happens in every 10 seconds, I would say, or 11 seconds, and they leverage microservices. Kubernetes is modular, and Amazon is another one who's the early adopter, right? I really don't need to talk more about containerizations, but looking into our AI specific one, basically it helps us the consistency, the managing consistency across environments. And then when you look at the Kubernetes, which is the container orchestration platform, which helps us scaling and the orchestration and the self-healing of AI workloads. Moving on, the serverless computing. Now, serverless computing is another really important piece when we manage our data and AI workloads. It helps us execute code without managing infrastructure, right? Now, in generative AI solutions, and when we build generative AI model or large language model applications, GPU as a service or inference as a service are two really critical things here. And this is where, making sure that our infrastructure has the capacity, our infrastructure is efficient enough to make sure that we can build the model, we can deploy the model, and we can achieve the low latency through the inference. And this is where the serverless GPUs are very important. Now, inference as a service, you can definitely leverage GPU, but also you have LPU such as Grok, which provides a faster inference as a service. Now, what are the benefits that we achieve out of leveraging serverless computing? One is the auto scaling. It allocates dynamically the resource based on the usage, and then cost efficiency is again pay only for execution time, and faster deployment really. And you are not, it is eliminating the overhead of managing the infrastructure. So these are the kind of three key benefits. There are so many, but for a developer and for a senior executive or the decision makers, these are the tangible benefits that we immediately see once we start leveraging serverless computing. What are the common use cases? Definitely there are tons of use cases, but in current scenario, and AI powered chatbots can be is one of the use cases. AI model inference, real time data processing using serverless ETL pipelines, extract, transform, and load, or extract, load and transfer, whatever we call it. These are the kind of use cases which help us managing the data and AI workflows with on demand resources. So moving on now, when we look at the managing data and AI solutions or scalable, making sure that it's scalable, we cannot ignore the storage side of it and the data management side of it, as well as MLOps, which is the extension of DevOps side of things. Now, when you look at the storage side of it, definitely data lake is there, which we leverage in the S3 or in AWS world, or Azure Data Lake Store Gen 2, or Delta Lake data warehouse, such as we have BigQuery, Snowflake, signups. There are a lot of things. And in generative AI, we cannot separate vector database such as Weaviate and Pinecone. There are so many which helps us store the embeddings for the generative AI applications, right? And the data processing tools, again, there are so many data processing tools, and Spark has been very popular in Google. GCP, data flow, Databricks is one of the best in the market in terms of the adoption. Now, in terms of scalability strategy, what should be our scalability strategy? Definitely, we can use the databases for the real-time AI workloads, or tiered storage, and the lifecycle policies must be there. And again, it should be surrounded with the data governance principles and the best data management best practices. Now, on the right hand side, if you look at MLOps to automate and scale AI workflows, really, if you want to innovate faster, if you have to achieve the faster time to market, MLOps is very important, and this integrates basically the DevOps best practices into AI model development, deployment, and monitoring. Now, what are some key components? So definitely, when you look at a machine learning pipeline, it starts from building your feature engineering, storing into the feature stores, building the model, creating the model versioning, and then deploying, and then monitoring and the bias detections, right, to make sure that no, it is prevented from it prevents drift, right? One of the examples could be, okay, if you look at the investment banking side or the retail banking, a lot of experience on the banking side of it. It uses MLOps to continuously update fraud detections model is one of the example. Risk management is another example. Hyper personalizations is another example, and this is where MLOps has been really beneficial managing large scale AI workloads and achieving the automations and the scale. Moving on, how should we think of the security and compliance? Because we really can separate security and compliance. And considering the generative AI adoption that is happening in the industry, and security and compliance remain really two critical enablers. And I'll just want to make it very high level here. And there are four parts when you think of the security and compliance. One is the privacy side of it, data privacy. The second is the encryptions, and the third is GTA, which is zero trust architecture based, which is super important, and then API vulnerabilities. In terms of the data privacy, we have to follow certain techniques such as implementing differential privacy to prevent a data leak, such as a data leakage, and then data masking, the anonymizations or the pseudonymizations, making sure that the PI data is not exposed, making sure that you are compliant with GDPR, HIPAA compliance for the healthcare, or the CCPA, which is California Consumer Protection Act. There are so many other regulations and different based on the jurisdictions or the countrywide regulation that you are in. When you look at the encryption, so definitely implement in a hardware security modules, HSMs, for key management. For example, if you want to look at in a certain tools or the services that you want to leverage on to build your generative AI or the AI solutions, making sure that it is a hardware security model HSM compliant. That is very important. Otherwise, your security office or the compliance team, they might not allow to use the service or the tools that you'll be using. Zero trust architecture, really, this is very simple here, making sure that you enforce least privilege access. Role-based access control is super important here. Continuous authentications with behavioral analytics and some sort of secure enclave computing as well. And not besides this, you also have the MFA, and that is also very important. OAuth2 for the API vulnerability. So how to secure the AI models, endpoint security, which is using an OAuth2 or the JSON Web Token, JWT, or mutual TLS or SSL 2.0. Web application firewall, again, is very important to make sure that it helps us secure API gateways to protect AI services, the endpoints. And it's really important to regularly conduct penetration testing, and your architecture must be privacy and security first. This is really very important when we are in the journey of building AI solutions in a cloud native architecture fashions. Now, how can we optimize the performance, right? Making sure that we are getting the right speed, we are getting the right efficiency, we are getting the right latency in terms of the inference. So I've just mentioned four things here. One is the infrastructure. You must ensure that your infrastructure is sized properly, right? So that means how to design an auto scale AI workloads based on demand, right? And then next is the model optimization. So what are some techniques that we can think to improve model training and the inference speed, right? And maybe quantizations is one of the approaches to reduce model size of the memory and while maintaining accuracy, right? The data locality, can the data be stored and processed in the same cloud region? And then what are some frameworks that we can really adopt for the AI accelerations, not only in terms of the development, but also in terms of the inference side of it. So for example, NVIDIA tracked on Hugging Face Optimum for LLM performance tuning, or Grok, which uses LPU, language processing unit, for really faster inference. Now I have developed one architecture which is a very naive RAG-based architecture, leveraging how we can implement RAG-based architecture leveraging cloud native capabilities. just to spend 10 seconds or the quick 20 30 seconds on the RAG, what exactly this means. Look, you have a lot of data on your in your organizations, and if you take any existing LLM or pre-trained model, it is not in your data, right? It is trained up to a certain point in time. Now, how to ensure that we achieve accuracy, and how we can make sure that okay, this is we are getting some expected results based on the correct information, so the real-time information. And this is where the RAG is very much popular, because we really cannot fine tune all the time. So you have the unstructured reference data, as you see a lot of PDF files, Word or text files. You chunk it and then you convert it into embedding, leveraging embedding APIs. You have tons of embedding APIs, OpenAI embeddings or Hugging Face embeddings. So there are a lot of embeddings, and you can just take a look, the leader, and just pick one and just move on. And then you load into vector database such as Pinecone or VV8, or you can also leverage Redis in Azure. There's this another tool as well, I forgot, but there are a lot of vector database, so you really don't need to worry on that. So this is the step one. The step two is the user interface side of it, and this is where multiple users will be sending their queries. And make sure that you have the load balancer, such as API gateways or Nginx load balancer. It comes to the APIs. It basically in a search into the vector database, right? The embedding API must be the same as the embedding API which was used earlier, right? And then it will retrieve the top key, so and the top 3 or top 5 based on your configurations. And then the query and the top and the retrieve documents are passed to LLM to get the answer, right? Now, how does it translate to the cloud native capability? Again, this is the RAG. It is not advanced RAG. But when you look at the load balancer side of it, which is to ensure that event distributions of request, right, which is very important. And we can also use a load balancer on the LLM side of it as well, which I have not shown in this diagram, in this architecture, but a load balancer is really critical, number one. Each of the front end side of it, the back end, the vector database, the prompt template, the LLM services are Docker containerized. And this is really important, because we don't want to create a monolith systems, and each component is containerized. Now we can also leverage container orchestrations like Kubernetes to manage each of these containers that I just mentioned, with each HPA horizontal pods autoscaler capability to ensure services scale up and down based on demand, which is important. Now, making sure that in this architecture, the security and the privacy, as I talked earlier, are leveraged, and the best practices are leveraged, such as Istio for service mesh, OAuth for API authentications, RBAC, data encryption, so on and so forth. Now, when you look at the vector database, it runs as a stateful Kubernetes service with persistent storage. Now, LLM hosting and LLM inferences are very important, which is based on the GPU nodes or optimized inference service such as Azure ML or AWS SageMaker, a lot of things. And then Grafana and Prometheus to monitor API latency, and ELK Stack, also you can leverage that. Now, where are we moving? What are some future trends? And these are the kind of 4 things that I mentioned. One is we are moving towards a kind of a AI-powered cloud automations through self-optimizing cloud architecture. This is really happening now. The second is how we can make sure that we can process AI closer to the data source. Right? This is really important. LLM ops is another really important piece, as we are trying to optimize our generative AI workloads, LLM-based workloads. And finally, the quantum computing and AI and emerging potential of quantum enhanced AI workloads. And that is also another future trend that I see. Look, this is a very small, quick 15 minutes presentations, but definitely, what I would like to see and what we have seen working with so many Fortune 500 organizations, in the adoption is really happening. The leaders which have already established certain foundation on their infrastructures are really accelerating their business value. But also the firms, the organizations in which have started to realize that okay, we have to leverage the cloud native applications to build a scalable data and AI applications. They are also definitely investing into their capabilities to make sure that they will stay ahead of and they will remain into their competitive advantage positions. That's it. Thank you very much.